Şimdiki sunumumuzun konusu Proof of Work ve uygulama alanları. Bu konuda bir sunum izleyeceğiz. Sunumunu yapmak üzere X-Power'dan Hasan Karahan'ı sahneye davet ediyorum. Hepimize iyi seyirler.
Merhaba, ismim Hasan Karahan and I am going to do the presentation in English. First of all, I would like to start by asking a few basic questions. Your hands please. And what about proof of stake? And how many of you know the difference between Sybil protection and the consensus algorithm? All right, so we will cover some of these basics, and then I will present a little bit of my project, of our project. All right. What is proof of work? In proof of work, a worker puts in some effort and then produces some proof that he actually did the work. And in this case, we have somebody who builds a tower, and the tower is supposed to be green. And as a project owner, I can just come and quickly verify that this tower has been built properly and it's green. And then I say it's all right. If it's not green, if it's some other color, if it's red, if the tower is shifted, then I can quickly verify that it's wrong. So this is the basic idea of proof of work, this asymmetry between investing a lot of time to build something, to produce a proof, and then to be able to efficiently verify it. In a computer environment, it's exactly the same. Here, what we do is we do some computational effort using something called SHA-256 hashing algorithm. There are also other hashing algorithms. And then we produce some number downstairs, that's the hash, which starts with some numbers. And we can efficiently verify this by just counting the leading zeros. That's proof of work. Very simple. So it takes time to produce this number, this hash, because it's very difficult to find it. You have to run the algorithm many, many times, but you can in milliseconds, in microseconds, just count the number of leading zeros and verify that the person who claims to have worked did actually the work. Where is proof of work used? Well, it can be used in spam control and in API rate limiting. Actually, it's not used there, but it could be, and it would solve a lot of problems. You could, for example, attach to emails a valid proof of work and then only forward them if the proof of work is correct, is correct, and that would immediately eliminate spam. And of course, in the context of blockchains, you can use it as a proxy for your identity. You can vest your identity with an amount of work, and you can prove that you have vested it, and computers can then verify that you are kind of a person. It's a proxy verification, but it's usually enough to do things in blockchains. And there is something called Sybil resistance, which is when you have a network of computers and you want to avoid this network to be attacked, then you want these validators to be kind of a people, and then only people with enough proof of work are privileged to participate as validators. That's the basic idea in blockchains. That's what people can do. And why would you use this? Why use this? Well, there are a few things. In blockchains, you want to have many people being validators, becoming validators. And for that, you need a lot of them. And you want the voting power of these validators to be equal, to be democratic. And since energy is already pre-distributed by nature, you can use this energy and process it in computer chips to create this proof of work and use it as a proxy identity for your network. What is proof of stake? We have proof of work, and I want to also mention proof of stake, but because that's another mechanism people use to create a proxy identity. Essentially, proof of stake is access to money. If you have money, you are somebody. If you don't have money, you're nobody. That's the essence of proof of stake. And by design, most monetary systems rely on a hierarchical system of distribution. And only the rich enough, with enough proof of stake, are privileged to participate as validators. That's the basic difference. But both of these systems work. They just use a different mechanism, but it's important to understand this difference. Why would you use proof of stake? Well, the thing is, with proof of work, you have to invest this amount of work, and in proof of stake, we live in mostly capitalist systems, and there rich people already have money. You don't have to distribute it. And since a monetary system is already present, it can be easier to attract validator entities. That's one of the main selling points of proof of stake. But the system it relies on, the fiat money system, is centralized by design. In each country, without exception, it's issued by a single central bank. So people with preferential access to that can, in theory, game it, but we hope that they are not going to do. All right, now, Sybil resistance versus consensus mechanism. Proof of work and proof of stake, they are not consensus mechanisms. They are Sybil protection mechanisms. They are a way in a digital environment to express identity. And it's important in distributed systems to provide this identity, and it's important to make starting validators hard. But it also needs to be easy, so it's kind of a contradiction. Why? It needs to be hard enough that you don't get an infinite amount of validators who might, then attack your system. So therefore it needs to be hard enough. But if it's too hard, then you have too few validators, and then essentially you have just, again, a kind of a pseudo-decentralized, actually centralized system. So if you make it too hard, it's a problem. If you make it too easy, it's a problem. So you have to really calibrate your system. And this is true for proof of work and proof of stake. And as mentioned, proof of work and proof of stake, they are not consensus mechanisms. In Bitcoin, we use something called the longest chain rule. I'm not going to elaborate on this. And in Avalanche, we rely on repeated sub-sampled voting. So people keep voting until some consensus is established and that a certain transaction is valid. I'm not going to elaborate on this because my focus in this talk is more on proof of work and proof of stake. All right, but you can do something else with proof of work. And that's what we do actually. We combine it with proof of stake. How do we do that? In Avalanche, we operate on Avalanche. The Avalanche mainnet is a proof of stake Sybil protected blockchain. And that means essentially rich people, protect the network against attacks. And it's fast because it uses this repeated sub-sampled voting consensus mechanism, and due to proof of stake, because a lot of people already have money, it has many validators, but it has a high Gini. So there are validators who have a lot of stake, and there are validators who have a few of them. What do we do in Xpower? Well, we issue tokens on Avalanche using proof of work. So if somebody comes and says, look, I have done a lot of work, then we say, okay, we acknowledge this, we verify his token, that the work has been done, and we give him a token. It's decentralized, so you can mint our tokens without us, being able to reject you. Because it operates on Avalanche, and you bring the proof of work with you that you did the work to be entitled to the token. And it's fast because the Avalanche C chain is fast because its consensus algorithm, repeated sub-sampled voting, is fast. This is an overview of our project. So we mine, anybody can mine, and then produce a nonce, which is the proof of work that you did the work, which is the proof, which you can present then to the Avalanche smart contract. We deployed on the C chain, and then you can mint it by paying some AVAX transaction fee, and then you get your X-Power token. We call it X-Power. And if you burn it, then you're entitled to get our NFTs. And if you stake those NFTs, you're entitled to get staking rewards, which we distribute as aged X-Power tokens. Essentially, what we do is we package your reward, which would originally be also in X-Power, into an A-Power to show that you actually, parked your capital into the NFT and were willing to wait, and this H-Power kind of encapsulates the opportunity cost. And if you burn the H-Power, you can unwrap the contained X-Power and go back into the scheme. This is the entire project we did so far. We have been working for about a year on it, and then we are going to implement lending and borrowing, where people can provide A-Power as collateral and then borrow X-Power. So in this sense, we are not using proof of work as a Sybil protection mechanism, at least yet. It's just a way to distribute tokens in a decentralized fashion. And because it's decentralized, and we didn't do an ICO, we didn't collect any money, because proof of work allows us to do this. It was a fair launch a year ago, and since then, at the first day, about 2,000 people minted our tokens and are now owner of these. Now, I keep talking about a single X-Power token, but that's actually not the case. We have 3 different tokens, and I'm going to first start with the Odin one, because when you create with proof of work this hash number, which has these leading zeros, then there are a few ways to reward your participants with tokens. One way is to reward them proportionally to the amount of work they have vested into creating that proof, and that's what Odin does. If, for example, the hash power starts with 1 0, he gets 16 tokens. If it starts with 2 zeros, he gets 256 tokens. Why steps of 16? The reason is simple, because the hash is a hexadecimal number. Each digit starts from 0 and goes to 15. And on the opposite end, we have the Tor token. The Tor token, when the hash starts with 1 0, you get 1 token. If it starts with 2 zeros, you get 2 tokens, and so on. So the supply of Tor is, compared to Odin, a lot lower. Why do we do this? Why this, why this difference? Well, I call Odin the capitalist, because it rewards you to the amount of work, proof of work you have put into the system proportionally. And Tor is also capitalist, but it rewards only those people who are willing to pay the transaction fee. So Odin is good for people who have access to good technology, mining technology. Tor is good for people who have access to a lot of AVAX. Loki is a compromise in between. So therefore Loki is kind of my favorite in terms of, fairness. You need a little bit of both, but you don't need to be a master of proof of work or being rich. Now, once you have these X-Power tokens, you can then turn them into NFTs, as mentioned, and our NFTs are on OpenSea. You can mint these X-Power tokens by burning these Tor, Loki, or Odin, and each year we issue a new collection. It's a single contract on Avalanche, but each year we can modify the metadata and add new pictures That's all we do, and then you can get for the current year an NFT. So if you want to mint an NFT of 2021, you have 7 days left. After that, these NFTs, they just become collections because the issue can only mint it during 2021. For example, 2022 and 2021 are now limited, and next year we will start with 2023. Our NFTs are split into 9 levels. According to the SC prefixes, unit, kilo, mega, giga, and so on. So if you want to mint a unit NFT, you have to burn a single X power token, which is a single X power token is easy to get. Therefore, minting a unit NFT is easy. If you want to mint a kilo NFT, you have to burn 1,000 X power tokens. It's 1,000-fold harder. Mega, 1 million times harder, and so on. So therefore, the supply of, for example, unit kilo, there's a lot of these. Mega is already few, giga is already few, and there are only so far 2 Tera NFTs. Nobody managed to mint peta or the higher orders. It's just too difficult. And they do not directly generate staking rewards. But you can buy them on OpenSea at the URL there. And once you stake these NFTs, we call them PPTs, perpetual bonds. So perpetual bonds keep rewarding you with tokens, and these tokens are A-power, aged X-power tokens, A-Tor, A-Loc, and A-Odin, and unit, because these are so easy to generate, they don't generate rewards. Kilo gives you 1%, mega 2%, and so on. Plus, older issues reward you a little bit more, 1 part in 10,000. And these keep increasing with each year passing. And you can also buy these at OpenSea. This is our return of investment on our NFTs. As you have seen, our APR rewards, they are relatively conservative. We didn't want to play this game where you attract people with 10,000 APR or something to avoid our aged X-power, A-power tokens to become worthless. And for example, with PETA NFTs, which nobody so far managed to mint, you would get a 10x in 50 years. So it's really conservative. Now, roadmap. I've told you what we have worked on in the last maybe 18 months. And what we are going to do is then we will implement lending and borrowing, where you can put up A-power as collateral and then borrow X-power in exchange. Then we are going to implement Hela token, so we will have a 4th token. Why a 4th token? If you have noticed, I've so far never talked about a bonding curve. Our original X-power tokens, they don't have a bonding curve. So anybody, if one person comes and mints 1 X-power per unit of time, then you get 1 X-power in a second. But if 1,000 people come and they mint 1,000 X-power per unit of time, then you have 1,000 X-power. So it doesn't limit you, because we didn't want our X-power tokens to become a store of value like Bitcoin. We didn't want them. We want them to be medium of exchanges. We want people to spend our X-power token. But if we do that, if we only do that, nobody comes, because they say there's nothing to gain for me. So therefore, we are going to introduce Hela, which will have a bonding curve. It will be restricted. There will be global restriction. 1 Hela per day will be mintable globally, and people will need to burn these aged X-power tokens, A-Tor, A-Loki, or A-Odin, and to be able to mint these Hela tokens, which will then also get NFTs. This is a Hela NFT, and then there will be also an aged Hela, which is the reward. Same scheme. And we are going also to introduce our Avalanche Gaming subnet integration, where we will start spending these tokens everybody keeps asking me, what is the utility? What is the utility? Well, one utility will be that you can use these X-Power tokens as to pay for transactions in our Avalanche subnet. And this is a demo of a game. You see, we have different coins here, yellow, green, and blue. And while gaming, people will be mining. People will be mining in the background, so 50% of the CPU will be spent on the game, and the other 50% will be spent on mining. So we are using essentially this game as a to attract gamers, and they cannot cheat this. Nobody kept talking during this whole event about how you can, prevent people from cheating in these games. And because we are using proof of work in the background, nobody will be able to, get these tokens by just playing the game, because the CPU has to provide the power to create the work. So you are entitled to collect these tokens, and at the end of the level, you can mint them by paying AVAX transaction fees. Thank you very much.